Most animals rely on their keen senses to determine if surroundings are friendly or hostile. Because humans aren't as gifted, we sometimes have to rely on other ways to sense how environment may affect us. One unique way is by using miniature fiber optic sensors that can monitor how systems interact with their environments. Since 1986, a small firm in Austin, Texas, called Systems and Processes Engineering Corporation, or SPEC, has been developing these tiny sensing technologies for many different applications. Over the years, SPEC has grown into other technology areas as well, and early in its history, the firm began a partnership with NASA through the Small Business Innovation Research, or SBIR program. Through an SBIR award from Goddard Space Flight Center, the company developed algorithms for a spark gallium arsenide processor that could be used on Sun computers. The work was a success for everyone involved.
NASA won because they got a commercial processor. Sun won because we were able to put Sun into NASA and into the federal government in a way that they had not had so far.
And the work led to other Phase 2 and 3 contracts for SPEC. In the mid-1990s, with an SBIR award from Langley Research Center, SPEC produced a miniaturized fiber optic distributed temperature sensor, or DTS, for aerospace structures. That technology, along with the processor for Goddard, was space qualified and integrated into a NASA mission. The DTS monitored the cryogenic tanks of the Lockheed X-33 space shuttle concept.
You have gallium arsenide on one side coming in from an investment from Goddard. You have fiber optic sensor investment from Langley, and everything comes together into something of a crescendo.
During that time, the company formed a new division called SensorTran to mature the DTS technology. Since then, SensorTran has found other applications for original DTS developed for NASA.
Today's customer base is primarily oil and gas related interests. About 90% of our business is there, measuring wellbore parameters downhole.
In the late 90s, with an SBIR contract from Johnson Space Center, SPEC created biosensors to monitor space habitat environments. These sensors will eventually be integrated into the health monitoring system of the biotechnology facility on board the International Space Station. SPEC's SBIR projects with NASA have benefited the firm in a number of ways.
It really affords us the opportunity to go investigate difficult areas with very high payoff. What that represents is really a great government partner. It affords us the opportunity to look at all of the applications in the government arena. And then it also affords us access to really great engineers and scientists at NASA.
Today, SPEC still partners with NASA. They're developing an onboard instrumentation system with Langley. The system will provide aerospace vehicle health monitoring via a fiber optic multi-sensor to monitor temperature, structural integrity, and corrosion. And you can be sure the system will be able to sense when something's not right in that environment.